Welcome to Weather and Forecasting. This is Module 10, and this is our part on tornadoes. And so tornadoes are extremely rapid rotating wind masses. They often will develop, they have to develop under at minimum a cumulus-nimbus cloud. That would be a thunderstorm cloud. So at the very minimum, I'm developing under a cumulus-nimbus cloud, but they can also develop under a tropical storm, and they can develop under hurricanes. So all of those more strong forms of rotational vertical cloud structures can also produce tornadoes. They have a wide variety of shapes and sizes, and they are one of the more researched, nuanced weather and forecasting things that are out there. They are small for radar screening, and so they're very hard to determine whether they're going to occur, which is why if you live in Tornado Alley, the locations where tornadoes are most likely to occur, specifically during what we consider tornado season, we just put out our standard set of warnings and hope that it gets to you in a timely manner to save lives. And while we've gotten better at forecasting tornadoes, it's still a growing science, and we're learning something new every day. So the weakest tornadoes have wind speeds that are fairly slow on their rotation. And by slow, that means that it's flowing at 65 miles per hour. And the reason for that is because I'm building a vortice. And in order to have a clearly sustained vortice, I must be rotating at a speed above 64 miles per hour. So same rules apply when we get to hurricanes as well. But to have that clearly defined vortice of rotation, it has to be 65 miles per hour up, or 64.9, right? As far as strongest wind speeds, some of the strongest rotational wind speeds on a tornado have clocked in at 280 miles per hour. And so we can get incredibly severe, strong stuff. Now, most tornadoes are incredibly short-lived, only lasting minutes when they actually touch down. And a tornado is not a tornado till it touches the ground. So if I have a rotational air, but it's occurring slightly aloft and does not touch the surface of the earth, it is not a tornado yet. And we're going to go through those locational names as we go through it. So one of the things we just talked about was those rolling clouds. And if I have a rolling cloud occurring in my air mass, I have this nice rotation happening, and that rotation gets pushed up, I can get a reaction that actually has a rotational air spinning on itself in that location. And if it has a cloud to ground contact, so I have this two actually touching from cloud to ground, I will call it a tornado in its formation. Now, tornadoes do not suck things up. They spin them around and rip them apart. So that vacuum concept on a tornado is not what happens. And when something gets picked up by the tornado, it either gets picked up and then flung around the rotational curve, getting thrown in the air, or gets picked up, hits a patch of weaker air, drops it, and then picks it up again. And so there's this action of actually lifting something up and slamming it to the ground, and then lifting it up and slamming it to the ground again. And these are just things that you need to keep straight. Don't think of a tornado like a vacuum. It is not a vacuum. So here is my lovely supercell thunderstorm, which means that I have a clearly defined updraft and a clearly defined downdraft, even though they didn't draw those images in. I also have that nice clean anvil shape on my vertical thunderstorm cloud on its set. I can see down here that in the corridor of the base of the tornado, I have a small tornado that has formed back here. I can see that I have my cloud wall, which means that I have a rolling cloud right in that location on this image. This here is the large hail mass on my cloud set. I can see some small hail that they're pointing out, the really heavy rain, and then the light rain up over here. But the beauty of this image is to give you a scale of how big the thunderstorm is. So how big is my supercell versus the actual size of the tornado, right, in its occurrence. Tornado formation, non-supercell development, I can get tornadoes that formulate their own clouds above them as they draw moisture into their rotation. And then they'll hit their dew point, which means the water will come out of suspension and it'll cause a cloud. Now, what makes the tornado visible? Because when it first begins its upwards rotation is the picking up of debris that it's carrying, as well as the dragging down of the solid and liquid particles of moisture within the cloud itself. And that's what makes it visible. So in the first moments, when I take my rolling cloud from the surface and I pop it vertically, it's not visible till I actually make it dirty, until I bring stuff into it to start carrying that around with its rotation. And so this is how I could create the formation of a tornado on just having a rolling surface cloud with a vertical updraft. So I just have a vertical updraft occurring that's a rotational vertical updraft, which then will formulate a cloud, and then that formulation of cloud will allow a cloud to ground connection. Now, sometimes I will just get this, and this is where I get dust clouds and small dust devils. These are small updrafts that are occurring that happen to be rotating, and this is where I get those little sub-Saharan Africa dust or sand devils that just kind of rotate. They don't feel like much, and they actually are kind of common on the beaches in California too. Sometimes you'll just see these little rotational sand dust devils. They're dust devils, and you can actually play in them. You know, sometimes you get hit with like a big rock, but you're like running through them. You're like, I'm in a tornado, but they're nothing. They're nothing. They're not strong, and they truly would not even register on the Fujita scale. And that is actually the force scale for tornadoes. As far as tornado formation around the world, the red dots are where I can expect tornado formation. This is why I said the United States, because of the shape of the continent, because of the shape and the shallow, warm water body of the Gulf of Mexico, and the Mojave Desert here, and the tropical air mass warm front that comes off of the Gulf of Mexico, mixing with the Mojave Desert continental tropical air here, which is being pushed by the polar front air. That is a continental polar that's pushing the continental tropical, that's forming a dry line, which is the line of separation between the moist tropical, maritime tropical, the MT air over here, from the dry tropical, the really hot dry air over here. So I formulate a dry line, will actually cause a natural formation of squall lines along that formation, which can then produce tornadoes from their thunderstorms. So the U.S. gets the award. We are the #1 place to get tornadoes, more so than anywhere else in the world. And it has to do with our continental shape. It's a natural structure. So talking about average annual tornado incidence, right? So average annual meaning yearly, right? How likely are they to occur? You can actually see the gray areas are more than 9 times in there. And you can see this is Tornado Alley along here. And Tornado Alley starts here in the early parts of my spring season, and then summer it moves this way, and then fall it kind of moves back. And so that's actually my draw line, which is also Tornado Alley on my set. There's also some other locations where I can get some pretty high occurrence of tornadoes, and some inland locations that pick up some rolling clouds that get bombarded with a whole lot of thunderstorms every afternoon, like Florida down here, right? So just giving you the possibility for tornado formation in location in the United States. As far as times of year, so tornadoes can happen all year round. And in certain parts of the United States, the chances of them happening at any point throughout the year are higher than in other parts of the United States, right? Like in these green regions over here. But as far as what we consider tornado season is from March to September on its set. That's what we consider our tornado season, March to September. As far as when they're most likely to occur, you can see that the biggest spike happens in May and then in June. And then it calms down a little a lot of the time for July, but that's not always true. Tornado damage